Hey everyone, my name is Kelvin. I'm a developer and I make free tutorial content. If you like this kind of thing, consider subscribing and liking the video. And if you want to support me in other ways, you're always welcome to buy me a coffee.
Hey everyone, I know it's been a while, but I've been writing some Go lately and I feel like it's about time I make another full stack app project tutorial thing. So yeah, let's get started. So the project that I want to start is a personal finance project. It's basically the expense trackers that you see pretty often, but I want to do this in Golang and the front end is to be determined, but probably React of some sort. But because this is going to be a full stack project, we're going to have all of our Go code inside of a server directory. And then once we're in here, we need to initialize the project. And we're going to do that with go mod init. Now the convention is that you use your GitHub account here as the first part of and then finally the project name as the second part. And let's actually open this up. So I'm going to open up the entire project directory, not just the server directory. It's pretty empty right now, but let's make a new file. And for now, let's just do a simple hello world. This is just so that we know everything works. So back in the terminal, let's just run go run main.go, and we got our hello world. And then one last thing I want to do is set up air. So air is a hot reload CLI app thing. It'll rebuild our Golang binary and run it every time it senses a code change. But first, while I scroll down, here it is. You'll need to install it if you don't already have it, and you can use this line here if you're going to use go install, or you can use this install script. But once you do, back in the terminal, I just want to call air init, and this will create a configuration file, a .air.toml file that has some default configurations. Now there is a lot of things here, but the important ones is basically these two. The command will build the main.go in the current directory, and then the bin will live inside of a tmp directory. Because of that, I'm going to add a getignore file here, because we don't actually want to commit this into our project. Speaking of which, I forgot to initialize this as a Git repository, so let's do that. So git init, let's add everything, and we'll commit it as initial commit. Now we're ready to set up our server. And to quickly go over what routing framework that we're going to be using, I'm going to be using Fiber for this project. So let's make sure that we add this to our project. So back in our terminal, let's clear this, and we'll quickly do a go get for Fiber, and this will, I'm not in the server. Okay, let's rerun that. And this will add the Fiber package and library into our project, which if you examine the go mod file, it's all here. And the go sum is also another place that you can see all the libraries that you added to your project. But now in main.go, we can create a new Fiber app by calling new, and we can serve that app by doing app.listen. Let's also make a hello world type of route right now. We're going to do app.get at the route of slash, and we want to respond with something that has a status code 200, and let's respond with a JSON that says hello world. Now, assuming everything works, we'll call air, and this is on port 4000. Okay, so at port 4000, we should get hello world. I think what I'm going to do now is add the database connection. And the library that I want to be using is sqlx. So we're going to want to get this first go get. This will get us the sqlx library. We're going to be using postgres, so we don't actually want this driver. We're going to use a different one. So let's kill air, get the sqlx library, and then the database driver that we're going to be using is pq. And before we actually do any Go code, we're going to want to add a database. So to do that, I will be using Docker, and we're going to add a service. Let's just call it FinanceDB. We're going to be using the Postgres image, exposing the ports, and I believe those are all the environment variables that we need. So the user is Postgres, the password is Postgres, and the database name is FinanceDB. And the Docker file is in the root of the project, so we will do docker compose up. And that should start our Postgres server. Now back in our editor, let's connect to the database. So we're going to call sqlx.connect, on Postgres, and because of this, we need to add the PQ database driver, and the connection string here is in this format. Okay, I think that's everything. So the host is localhost, the port is 5432, user is Postgres, password is Postgres, DB name is finance, or no, yeah, that's right. And SSL mode we're going to disable for now. And if there's an error, we're going to do log.fatal with the format string. This way we'll print out to the logs that, what the error actually was. And let's do something with the database connection. I'm going to expand our get route and do a simple select one. We'll combine the result to a variable of type int. If there's an error, we'll just send a 500 response with the error message. And then I'm going to add another part to our response, our hello world response, so that we know that the database is available. I really should relearn tmux. These multiple terminal windows is kind of annoying. And then in another terminal, let's make sure that error is running. So then we check our slash route, which is in this tab, and do a refresh. And we now know that the database is available. Now let's do some refactoring, because a few things is not so great with this code. One is that everything's in one file. The project structure is kind of messy, and also all of this should be hidden away in a environment or a configuration file at the very least. Alright, so to address the project structure, we're going to be using the Golang standards project layout. We're going to implement this as best as we can. And then for the environment variables or the configuration, I'm just going to go use go.env, so we'll have our own .env file. So that means we're going to need to do another go get. This time we're getting go.env, and then inside of the server we're also going to make a .env file. Make sure to add that to your .gitignore file as well. Now it is a little annoying that the env file has to live within the server directory, but I mean, that's a minor nitpick, it's not super important. But because I'm gonna commit this to GitHub, I will also add an example.env file so that you'll know what environment variables that you'll need if you're just reading the code from GitHub. So right now I'm just gonna add some variables that I know that we need. So that'll be the HTTP port, as well as the database host, user, password, and name. And these are also the same ones that we created on our Docker compose file. Let's make sure that we copy this and add it to our real.env file, so our application will work as intended. So now, inside of internal/config, I'll make a load.go file. And this is package config, and here I'm going to use go.env to load our environment variables. And of course, if there's an error, we'll do log.fatal, and we'll send the error back to our terminal. Now I'm going to make a config struct here so that we'll have our environment variables readily available within our program. And of course, the two things that we have is the port and the database URL. So I just stubbed out two private functions here to load and return the actual environment variable, but I'm going to change load here to return a pointer to a config, where it will then call the private functions that we defined. Now for port, we could use os.get, pointing at our environment variable and returning it. Now for safety, we could do some string conversion here, making sure that the HTTP port is a number before we return it. And then similarly, the database URL, if we go back to main.go, is in this format, which is a little annoying, but we can use a function called sprintf and create a format string based on our environment variables. Now be careful a little bit because it is in this order, but we're using host, port, user, password, and name here, and what's being returned is essentially this commented out string, which I can get rid of. So that's our config package. Now let's create our database package, and we just want to do the same connection. So assuming that we are provided a database URL, we should get the connection, which is a sqlx.db. And then we'll call sqlx.connect, just like we did in our previous main.go file. I also added a print line here so that we know that we connected to the database. And then finally, let's also make a server file. And because I can't think of a good file name, I'll just call it main.go. And this server is going to be a struct where we define our entire application. So it's going to hold our router, the fiber router, as well as the sqlx DB. And it's also going to have the port string here. And that's going to be important for a little later. But in our function of new server, we're going to initialize a new fiber route or fiber application, as well as our database connection. And here's where we could return the pointer to a server, where we add all of these things that we just initialized into the properties of the server struct. And now I'm going to add two methods to the server struct. So the start method will start the fiber application on the port that was given. And that's why we needed it in the server struct, because we're using it later outside the initialization. And then stop will close the database and then the fiber app. This way we can have a graceful shutdown so that everything turns off in the correct order. Now that we have the config, database, and server all implemented in our internal package, we can update the main.go to call all of that in the things. So let's update main.go to include the graceful shutdown, and hopefully everything is going correctly. So first we'll load the config, then we'll create a new server, and we're going to start the server in a Go routine, so it's going to be on a separate thread. This is so that we can monitor the actual server from a distance, I guess is a way to say it. But this is mainly so that we can stop it manually if we need to. So we're making a channel here that we can listen to, and if we receive a signal that the server shut down unexpectedly, we can stop it from here. And we'll give it a timeout of 5 seconds so that the server can try to shut things down gracefully within those 5 seconds. And then finally, we'll just stop it manually if it goes past the cancel. So let's see if air is still running. No, it's not. Oh no, postgres driver. Oh, did we not add the driver? Connects. We did not. Okay, that should fix that. There we go. And I didn't add the routes this time. We're gonna do that later, but if we do refresh, it just should say cannot get. We'll also fix this. I don't like this either. But if we cancel, we should get. No, that's. Alright. I guess it doesn't disconnect if we cancel from air, but that's okay. Anyways, I think that's a good stopping point. So let's make a commit. I like everything, so let's just add everything. Let's make sure that our environment variable or our real.dnv isn't here, and yeah, that looks good. Alright. Oh, and if you're wondering what this is lazy git. It just makes the whole git experience a little easier, so I like it. Okay, so I think that's a good git commit message. So we set up the server configuration, and yeah. Oh, it looks like there's a problem with the go mod, and it seems that I didn't run go mod tidy, so we could go ahead and do that. And that's better. So now it's separated with all of our direct dependencies, the ones that we're using, and then all of the indirect ones, which is the dependencies that of our dependencies, which we need in our program, but we're not calling them directly. But now what I want to do is to set up our routes. So let's go ahead and make a new file. And I'm making the routes.go file inside of the server package. This is so that we have access to the server struct. So setup routes is a method on the struct instead of just a function. That way we have access to the fiber app. And I do want our entire API to be prefixed with /API. So we're gonna make a route group here. Now let's go ahead and define our root route for the API. And we're just gonna add in that same health check endpoint that we had earlier. So with the initial scaffold, it'll look like this, but we can extract this anonymous function into its own function. And that'll look something like this. Now we are returning a fiber handler here, and that's mostly because I want to get the database as an argument, just so we can rerun the select one query and make sure that our database is available. And what we'll do is we'll rerun the select one and get the result, bind it to the variable result. we don't really need to use the result variable, but what we're interested in is the error. And if there is an error, we'll return a false success, telling the user that the database is unavailable with a status code of 500. And then finally, if it is available, we'll send us a status 200 and success is true. And then our health check should be good to go. So let's test that right now. Now, since this is a simple GET request, you can use the browser, but I'm gonna go ahead and start using Insomniac, which is a request HTTP application thing. It's a helper tool. But you could also use Postman, which is probably more popular, but I don't know. I like this. So anyways, cannot get /API. Oh, I know what's wrong. I forgot to actually call setup routes. So in server main, let's add that here inside of start. All right, that should fix that. Make sure that error is running and it reran. So now if we just press send, we get a 200. And it also tells us that we have our database connection. So that's good. So before we actually write out our entire application, there's two things I want to do. One is error handling, and also I do want to create a route envelope so that all of our responses are generalized and have like the same format. I'm gonna make a new subpackage here called router, and we'll have two files, error and response. For the default error handler, let's just start with the example that's given in the Fiber docs, and we'll update this as we need, but for now, I think this is good enough. Well, not quite. Let's actually change this. Yeah, I think this will work for now. So just to quickly explain what's going on, we're gonna set the default status code to 500 or status internal server error. This is a good point to mention. Fiber does provide all the status codes, so we should be using this instead of just the raw integer. And then errors.as is going to read the error as a Fiber error, which does have code and message, so it'll have the status code as well as the message. And then finally we'll associate the correct status code and then whatever the error message. I think it would also be a good idea to print out the error, like just so that if we test it, we can actually see it in our logs. So let's do that too. Now inside of the response file, I do want a generic response function so that we could have everything respond in JSON. And let's also get the status code as well as the data, whatever. And data is going to be in of the type of interface, so it could be anything basically. And the JSON that we want is success true, and data is whatever data is coming in. Let's actually add success to the error response as well. So that should go here. And then, and you know what? Let's also add some metadata. This way we could have some useful information on the client side or the API side of things that we might need in the request. Now, path and method is going to be coming from the Fiber context. And then I also think the timestamp is always useful, so we're going to do time.now, so we'll know the time of the request as well. And then while we're here, I'm also going to add OK and created, which are just higher order functions, kind of, that will query over the status codes, so then we just need the context and the data, and it'll make things a little bit easier for us. We could make other ones for the other status codes, but I think these two are the most commonly used, so let's just start with this. And I suppose we could test this out with adding it to our health check. So let's go over here, and we change this last return to use our router.ok. I forgot that I need to pass in the context, so let's do that. And then for our error, we could just return a new error. And that should be taken care of by our error response, which I believe I did not add to the config. So we'll need to do that. So fiber.new takes in a Fiber config, which has a field of error handler where we could pass in our default error handler. Now with those changes, we can test it out in Insomnia again. So our health check should now include our metadata. So let's check that. And it does. And then we could test out the 404 with any route. So I'll just pass in any. And this currently is the expected error. I suppose we could add the metadata here, but why not? Let's add that. And once again, because this is in the same package of router, we do have access to the private function of generate metadata. So we just pass in the context, and now we could have our associated metadata. Okay, so I'm pretty happy with the server and router setup. So let's, well, actually, before I forget, let's make sure we commit all of these changes. Everything looks good, so, and this will be my commit message. We added the API envelope, a default error handling, and we also set up our routes. So this is setting up our router configuration. All right, have to submit this way. And now we're ready to actually create our application with all of the data transformations or storage and everything. So we'll go ahead and start doing that.